Hey Math 3, today we are solving absolute value inequalities. Remember, if guided notes are bothering you, you are welcome to take notes on a piece of paper and then just type in the private comments, I promise I watched the video and took notes. The goal is just for you to watch these videos and have notes going into class. So inequalities are different than equations because the inequality less than, greater than, less than or equal to, greater than or equal to represents whole sets of numbers. So our solution sets, it's going to be important that we put those on number lines and we're able to visualize the entire solution set. Step 1, get the absolute value by itself on one side, split the inequality into two. The left side, we're going to flip the inequality and change the sign of the constant, which is just the number or what's on the right side after the inequality symbol. Our right side inequality, we're just going to copy down, but without the absolute value signs. Sorry. Okay, step 3, solve each inequality. Step 4, we're going to graph. So a cool trick that I actually just learned last year from the Math 3 PLT is less than and less than or equal to. Less than becomes and solutions, which means on our number line, we're going to see those solutions overlap. Greater than or equal to, greater becomes or solution. So if it's a less than, my solution is an and. Less than, greater is going to be a greater or. The last thing you want to do is check both solutions. It is also important for you to remember that when you divide or multiply, so this one also needs to be filled out, by a negative, the inequality sign flips. So I am going to do the odds, and tonight you are going to try the evens. So let's look at some of these together. Oops, I do need that one. Silly. Sorry about that, y'all. Come on, come back up. All right, it's pulling on my other screen. Swear I'm going to get better. I'm going to get better. Okay, so number 1, we have the absolute value of 2x minus 1 is less than 11. So I wanted this up so that we could, just like I'm going to encourage you guys, go through the steps as you solve it. So step 1, get the absolute value by itself on one side. This is by itself because there's nothing outside those bars on that side. So when I split the inequality into 2, the left inequality, I'm going to flip this inequality and then change the sign of that constant, which is 11. On my right side, I'm just copying it down, but now without the absolute value. From here, it should be very easy because we're just solving 2x greater than negative 10, divide by 2, x is greater than negative 5. You guys are amazing at solving. So over here, we'd get x is less than 6. So on my number line, I have 0, 2, 4, 6, negative 2, 4, negative 6. So negative 5 greater than negative 5, don't include it. And then it says less than 6, so don't include it. See how this is a less than sign? That means these are going to overlap but stop at those boundaries. So my solution graph is actually going to look like that. All right, let's try number 3. Okay, so I forgot to check number 1, so we'll have to go back to that. So step 1, we want to make sure we get the absolute value by itself. So I want to subtract this 4 because it's outside of these bars here, so it's got to move before I split it. That's really important, and that's a big common mistake from a lot of kids. All right, so I get 56. Now I have my absolute value all by itself, so I can split the 2. So 6 minus 2a, flip my inequality, change the sign, copy this side without the absolute value. We're going to solve this, so subtract 6, negative 2a less than or equal to negative 62, divide by negative. So here I'm dividing by a negative, so this inequality sign is going to flip, and I get a is greater than or equal to 31. Over here, same steps, I'm just working with a different starting number. So same thing, when I divide by this negative, my inequality, which should be or equal to, is going to flip. So I did not flip it. Make sure you flip it. All right, on my number line, if I look at these solutions, so I'm going to just count by 10. So 10, 20, 30. So this would be 40. 10, negative 10, negative 20, negative 30, negative 40. So greater than or equal to 31. So I would be like here, solid that way. And then less than or equal to negative 25. So right between negative 20 and negative 30, less than that. So this is a or because my arrows are going opposite directions. And if I look, this was a gray or sign. So that's great. Now I just want to check. When you check, you always use the original. And I'm just going to pick a solution that would be in my solution set, because remember, inequality means there's a whole set of solutions. So maybe I want to check absolute value of 6a plus 4 greater than or equal to 60. So let's try negative 40. And I just want to make sure that that works. So negative 2 times negative 40 is 80. 80 plus 6 would mean the absolute value of 86 plus 4 is 86 plus 4 greater than or equal to 60. Yes, that's 90. 90 is greater than or equal to 60. Then I want to just check a solution over here. So maybe I want to use positive 40. So absolute value of 6 minus 2 times positive 40 plus 4, and I want to make sure that that's greater than or equal to. So that would give me negative 80. So 6 minus negative 80 actually is negative 74. So negative 74 is 74 away from 0. So is 78 greater than or equal to 60? Yes. So that's how you would check your solution. Okay, let's move on to number 5. So here we go. I need to get the absolute value by itself. So I have to move this 18 first because that 2 is attached, so it's going to go last. Remember, when we isolate things, we do order of operations backwards. So we want to do this backwards. So the subtraction and adding would come before this multiplying. This 2 is multiplying here. All right, so that gives me 10. Now I need to move that 2. So I'm going to divide everything by 2. Absolute value of what plus 4 is greater than 5. So now I split. Left side, flip the inequality, change the sign. Right side, just copy down and solve. X is less than negative 4. X is greater than 1. So on my number line, here's 0. We'll count by 2's. So negative 2, 4, 6, 8. Didn't give myself quite enough room. We'll go to negative 10. So X is less than negative 9. So negative 9 would be here, less than. X is greater than 1 would be here. So I see an or because they're pointing opposite direction. My solution can't be and. It's not in between. It's either over here or it's over here. And I did start with a gray or, so that's great. I'm just going to put an or here. So that's the written form, and then there's the graphing form. You should check it. Number 7, isolate the absolute value, get it by itself. So I'm going to subtract 4. Absolute value of 7 minus x is less than 6. Make it into 2. Flip the inequality, change the sign, copy it right down. So subtract 7, negative x greater than negative 13. Divide by a negative, flips my inequality. Same steps over here. I just started with a different number. Divide by a negative, flips this inequality. So that is going to actually flip where I see my solutions as well. So I have negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so less than 13, open circle to the left, greater than 1, open circle to the right. You see how this solution is going to overlap? So this is an and. So I have less than. So my solution is x is less than 1 and x is, greater than 1 and x is less than 13. Sometimes you will see this like this, where the x will be in the middle, like we saw with our piecewise, and I'm going to say x is less than 13 and x is greater than 1. These inequalities will always face the same direction. I will give you credit for this or this, but just know that you can see either method on tests and assessments. Okay, last one is number 9. So we need to get our absolute value by itself on one side. So I'm going to subtract 6. Absolute value of 2x minus 5 is greater than negative 2. So if I pause, sorry about that, and just think for a minute before I just operate like a robot, this is saying what has a distance that's greater than negative 2? Well, distance is always positive, and all positive numbers are greater than negative 2. So this is actually going to be all real numbers. When I work it out, we're going to see what this looks like graphically. So I'm going to split it, change the sign of that side, right? Flip the inequality, change the sign, copy this one down. Solve them. So 2x is less than 7. This time I'll use decimal, so 3.5. It's fine if you want to write it as an improper 7 over 2. Over here, I would get 2x is greater than 3. So x is greater than 1.5, or you can write it as 3 over 2. So when I go to my number line, 0, 1, 2, 3, 4, 5. All right. So less than 3.5, greater or greater than 1.5. So if something is less than this or greater than that, do you guys see how this is going to include all numbers, because I can be over here or over here? Actually just means that I could draw my line like this. All right, please try the evens and be ready to check your work tomorrow.